Welcome to our podcast on the future of sustainable water transport. Road and rail networks are increasingly reaching their capacity limits. At the same time, the demand for environmentally friendly and efficient transport solutions is growing. This is exactly where the AUTOFLEX project comes in. By developing autonomous, sustainable, and versatile small vessels for transport on inland waterways. In this podcast, we follow the AUTOFLEX project and take a look behind the scenes of its research and development. Together with experts, we discuss innovative vessel concepts, autonomous navigation systems, sustainable propulsion technologies, and the challenges that must be overcome on the path to a new generation of water transport. Innovation on inland waterways, autonomous, flexible, sustainable. Welcome to the podcast. In this episode, we take a closer look at the relationship between ship design, safety, and automation in the future of inland waterway transport. Rather than treating technologies such as autonomous navigation or electric propulsion as standalone innovations, our discussion explores how they influence the entire vessel as a system and what this means for the design of next-generation cargo ships. Drawing on both historic developments and modern engineering challenges, we examine how shipping has gradually evolved from human-centered operation towards increasingly automated systems. The conversation highlights the concept of safety by design, the unique regulatory and operational challenges of inland navigation, and the fundamental question of how autonomous vessels can be made safe, practical, and economically viable. Ultimately, this episode argues that the future of autonomous shipping depends not only on new technologies, but also on rethinking the ways ships are designed, regulated, and operated. Our first guest is Dr. Igor Bačkalov from DST. Igor is a renowned naval architect, researcher, and former academic specializing in ship stability, maritime safety, and autonomous vessels. He also serves as the vice chair of the European Council of Maritime Applied Research and Development. Returning to the show is Kristoffer Kloch from DFDS, an expert in maritime logistics, innovation, and sustainable transportation. Kristoffer is the project manager for AUTOFLEX, a major innovation initiative pushing the boundaries of autonomous shipping.
So when we talk about design of autonomous ships, or let's say design of the ships which involve a lot of innovative technologies, be it zero emission, be it automation, be it something else, then we typically focus on that specific aspect. So how to implement a certain, let's say, propulsion system, or how to implement certain remote navigation module and so on. And then we forget about the rest. And I think this is, I always thought that this is a very, but I didn't have anything to prove it with, but I always felt and thought that this is a very inexperienced approach. So the people who perhaps did not do much ship design, they, do not take this, let's say, implementation holistically into account. So when we started doing the AUTOFLEX project, I was very happy to see that the first task within the project has this title, Impact of Technologies on Ship Design. And I saw this as an opportunity. And I saw two opportunities there. The first opportunity was to examine this whole, from the holistic point of view, the whole impact of the new technologies on the design. So to take all the classic, fundamental, basic naval architecture aspects into consideration, and to see how these basic aspects interact and how they are impacted by these new technologies. That was the first opportunity. And the second opportunity was related really to this standardized design. So is there an opportunity there to standardize a design of a future small inland cargo vessel, which is then incorporating, so it's a sort of a 21st century small inland cargo vessel, or at least the first half of the 21st century small inland cargo vessel. So with that ambition to provide a blueprint for something that can be then produced in great numbers in future. So people who know me, I have these pharaonic ambitions always. I start with that, and then maybe we achieve something in the meantime. But yeah, these were let's say the two opportunities that I saw in the very beginning.
Yeah.
And then I approached this really as a naval architect. So I tried not to focus on the new technologies per se, but to think about the ship as a system. And then when we come to the point that we need to introduce, let's say, a wheelhouse, then the automation of navigation comes into play. But this, let's say, navigation is different than on conventional ships, and then you start thinking how to implement this in the design as a whole. So not starting with the new system, but starting with the ship as a system, and then implementing new systems.
Yeah, because I actually think, I've said this to you before, I think one of my favorite things so far, we're not done yet, but one of my favorite things from the AUTOFLEX project in terms of deliverables or in terms of sort of dissemination is this paper you did on looking at the history of inland vessels, where sort of we ended up with the Oscar too, and we'll talk about this in a second. But I think for me, and we just before starting to record, we talked about the walking tour we did in Copenhagen as part of one of the general assemblies, where we actually looked at the old port in the middle of Copenhagen and saw how it moved out. It's so important, I personally think, that we anchor these sort of things in what used to be, because otherwise we continue to reinvent the wheels and reinvent the wheel and reinvent the wheel. So genuinely, one of the things I've enjoyed the most here is that we say, okay, but how has the inland waterway fleet developed before the war, especially after the World War? And the presentation you did as well at the university the other day, where you saw the difference also between self-propelled ships and non-self-propelled ships, you know, I think is very important.
So I think we generally sort of skip these evolutions. That's a very, very strange approach in my view. So if there is an evolutionary development, then we need to understand why, how, what's behind this trend. And also in ship design, we rarely start from scratch. Even if we do something very innovative, we really rarely start from scratch. So we try to build, I mean, what we need to understand is that shipbuilding, shipping, all of these, let's say, related disciplines, this is one of the oldest human traits. So it is something that has started thousands of years ago. And this has two aspects. One,
or even more. Which you can say, like, even at the age of, the beginning of man, you can say, like, you might have used the waterway to transport things.
Exactly. So first it was a log. It started with a log, and then it progressed. But there are some aspects that we tend to neglect. One of the aspects is related to this introduction of technologies which replace human labor, human mental work, human physical work, and so on. Because we say that ship safety is composed of two components, which are complementary. So we have safety by design and safety in operation. Safety by design are the technical measures. Safety in operation is something which is achieved by skillful, well-trained, experienced master and his or her crew.
Or some would even argue, I'm not one of those, but to play the devil's advocate, some would even argue that some of the procedures and ISM code for seagoing ships, at least, is also part of the operational safety.
Exactly.
So, although there's a lot of human factors, I would say, if you make too many procedures and you not standardize, but if you make this too rigid, where people are not thinking for themselves, you actually increase the risk rather than decrease the risk. But that's another conversation.
It becomes complex at some point, especially when you look into the human factors. But nevertheless, we have these two components. And when you look into the history of the shipping, this trend of decreasing safety in operation by, simultaneously increasing safety by design. So, I mean, you need to have, it has to be one. It always has to be one. So if you decrease one, you need to increase the other. And this has been happening for, ever since we started sailing. So this is not a very new thing. And I'm surprised that we sort of missed this part of the picture. So it has been constantly the involvement of a human in shipping is on board.
Yes, yeah.
On board, not in shipping in general, but on board has been constantly decreasing. So when Magellan sailed around the world, there were 5 ships. Altogether, there were, 300 people on board these 5 ships. On his ship, his, let's say, flagship of his expedition, there were, 66 people.
Right. Yeah.
And the ships were between, 20 and 25 meters. And then you have, today, you have a 400 meters container ship, and you have a complement of 22.
Yeah, and that's high. I would even.
And that's high, and that's on the high end, and exactly.
My last, just sorry for interrupting. Yeah. My last, I'm a 4 seafarer, and the last ship I was on was an oil tanker, so it was a different type. It was fully loaded, 150,000 tons of cargo, and I think we were 12 or 13 persons on board. Yeah, maybe a little bit more, but that's still the number.
That's the order of magnitude. So, we should ask ourselves, how is that possible? And it is possible because human labor has been replaced by systems. So it is a trend which is going on for centuries, for thousands of years. So eventually, humans will leave the ship. They will not be left out of the equation, but they will be gradually moving to different positions. The point is that in future we may need better ship designers.
To accommodate for that, as you said, right?
Exactly.
When you decrease the operational safety of having a human on board, you have to increase the, what you call it, architectural maybe? Or ship design?
Call it whatever you like. Yeah. We typically say it's safety by design.
Sorry, yes, safety by design.
That's a sort of a term that is being used. But the point is that these are the technical measures. Now, when we go to inland navigation, because our project is about inland navigation, there is a very interesting paradox there. If you look into the technical regulations, then you will see that actually, if you compare it to the maritime ships, to the seagoing ships, and to the rules for the seagoing ships, you're going to notice that the share of the safety by design measures in inland navigation is much smaller than comparably smaller than in seagoing shipping. Because in seagoing shipping, you already have lots of sensors, lots of systems that can be activated from distance, fire safety systems which are either automated or can be activated from a remote position. You have a lot of sensors which are acquiring information. And of course, nowadays you have lots of decision support systems, weather routing, and so on. But in inland navigation, when you look into the regulations, you're going to see that a lot has been expected from people on board.
Right. Okay.
So there isn't so much automation. Of course, there is a difference between what is required by the rules and what has been implemented, because in Western Europe, in specific, the ships are being equipped much more, on the average, much more than they are required to. But this depends on a company, it depends on the owner, it depends on someone's preferences. It is not required.
So and that might be more than a sort of a financial risk mitigation, right? Because I'm thinking as a ship operator, I want to maybe outfit my ship more because it's a relatively expensive asset to make sure that I can
but it's not always the case. When we compare things, we need to compare things, on a level playing field. So when we compare, we should either compare the rules. So we compare the technical standards for seagoing ships and technical standards for inland vessels. When you compare these two, then you come out with a finding that the safety by design measures are relatively less in inland shipping, and more is expected from people who are on board. The paradox part comes in when you see the required number of people on board, the minimum crew,
I guess it's lower.
which is very, very low. So you have between 2 and 5 people. 2 and 5 people.
Yeah, okay.
You know, and these between 2 and 5 are expected to do a lot.
Do the work of the 20 persons.
Do a work of the 66 persons on Magellan ship without the support, without the adequate support of systems. So inland navigation in this respect, and then when you bring automation into this equation, it becomes very, very interesting field. Because then you realize that actually, if you want to go towards, let's say, autonomous ships, to use this more generic term, more, let's say, umbrella term.
Which is another concept we can dive into.
Exactly.
If you want to.
Yeah. But if we want to go to that in that direction, then we actually need to introduce much more.
By design, you mean?
By design, because our starting point is lower than the starting point of seagoing ships.
Yes.
And this is typically, we typically miss to understand this.
And why is that, Igor? I don't know. I mean, why is it that the...
Because there is this, so this is my point of view. I don't know, I mean, but how I understand it is that there is this, let's say, mythical perception that inland navigation is safe, per se. But then safety is a relative thing. So there is no absolute safety. Safety is something that we agreed upon. So the rules that we have in place, which are sort of safeguards, they do not define minimum safety or average safety. It is only, you know, the level of safety that we placed in a sort of a societal contract, which is not written, but this is something that we agreed upon as a society. And when we were writing this contract, when we were devising this contract, there was this strange idea that inland navigation is safe. But to understand, is it safe or not, we need to compare it to something.
Right, yeah, okay.
Part of this idea about safety of inland navigation comes from the fact that you can see the shore. So when you're outside in the ocean, you don't see the shore, you feel like you're alone in the world, and therefore you need a lot of safety systems to help you to survive, to evacuate if needed, and so on. And in inland navigation, we say, shore is there, so we can. But in practice, we see that, I mean, the fact that the shore is there doesn't mean anything.
Sometimes it might ironically actually restrict what you can do in a given situation. You know?
Exactly. And it can be even, I mean, very frustrating, actually, which does not help in hazardous situations. I mean, you see the shore, but there's nothing that you can do. I mean, you cannot reach it. It's even you know, it's getting you down.
Yeah, that's what so I have my expertise in sort of ocean going or short sea shipping, and there are a lot of the problems. If you want to talk about autonomy from an anti-collision perspective, some of the problems you have in that space is that you have sort of infinite dimensional space, which means I could steer however I want, to be a little sort of provocative. I could go hard starboard, hard port, 5 degrees. I could do many different things. But in an inland waterway, it's simpler. I'll do quotation mark for those who are not seeing what I'm doing. It's simpler in the sense of you have parallel traffic, so like on roads, but it's more complex in the sense of you don't have this almost infinite dimensionality because you cannot just go hard starboard. You know?
Exactly, and unless you're in a canal, if you're in a free-flowing river, your road does not have the same elevation everywhere.
Right, so
which then affects the hydrodynamics of the vessel, so you need to take care much more. Are you really within the lane?
Yeah.
So you don't have much margin, I mean, relatively speaking, especially because these are, at the end of the day, these are large objects with lots of inertia.
Yes.
So you need to take into account that, yes, it is a parallel traffic, but that's the only similarity.
And even sometimes it's not, right?
Even sometimes it's not, indeed. So, I mean, because of different, let's say, I would say, misconceptions, we have this situation where we have a low number of people on board, and in the same time we have low requirements with respect to technical measures. And then when we want to introduce automation, then we need to start from, let's say, a lower position and to introduce more, actually. And actually to introduce some things which are nowadays rather normal in seagoing shipping. You know?
Because that was my next question. What could be an example of I won't say a new, but a high-end parameter from the viewpoint of the safety by design?
I did an analysis some years ago of the technical standards for inland vessels in Europe, and this analysis was exactly from the point of view of autonomous ships. So, what are the obstacles within the regulations that could prevent the introduction of autonomous ships? And then there is a I think very nice concept which, to my knowledge, was introduced by Bureau Veritas. They look into the when they look into the involvement of a human in operation of a ship, they look into the 4 phases. They divide this in 4 phases. So the first phase is acquiring information. Then the second phase is decision making based on the second phase is actually the analysis. So you analyze the information that you have acquired. Based on this analysis, in the third phase, you make a decision. And then once the decision is made, you proceed to action. So acquiring information, analysis of information, decision making, and action. And then when you look into these 4 phases of human involvement, then you overlay this sort of with the regulations, then you see that the most of the gaps are in the first and the fourth phase.
Okay.
So the first phase is acquiring of information, because it is expected that most of the information actually are acquired by hearing or seeing, so using your own, let's say, physiological abilities without the necessary support of some systems. So there are no sensors which are required.
And even that, I could imagine, is so difficult because a lot of the things we pick up as humans is very tacit. You don't necessarily, you're not conscious.
Yeah.
Again, sorry for interrupting all the time. When I was sailing, for instance, you can easily hear when the turbo would kick in the engine. You know, these sort of things. Or you could feel the vibration would change a little bit on the ship, you know, and these sort of things tells you a lot on what is happening, you know, which might be what people describe as a gut feeling. Obviously, it's not necessarily a feeling in the gut, but it's like something you pick up through your senses, as you say, but you can't really pinpoint it. And the reason I'm saying this is because I would imagine that then, well, if you want to try to digitalize, in lack of a better word, that sensory system of a human being, it's very difficult, I guess, to pick up those sort of, you know,
Exactly. So what we need to improve is first the acquisition of information.
Yeah.
So we need more, I mean, simply speaking, we need more sensors that could help us, you know, understand and could give us an early warning of a dangerous situation. And then if we go to the, let's say, fourth phase, action. This means that we should enable the operator to activate a certain system from a distance. So nowadays it is expected that you tend to the problem. I mean, you physically walk to the specific.
Acknowledge the alarm.
Exactly, and you take the action. You know, you take a hose and you try to extinguish the fire. And so these 2 phases are, let's say, the most urgent ones to be addressed if we want to move towards, say, more autonomy.
Yeah. And how, because to return back to the AUTOFLEX ship particularly, how, like, because we settled on a CMT Class 2 ship, which is a very, very small one, 24 TEU, I think is the last design. Why that size, and does that size offer anything special in terms of this safety by design way of thinking?
I wouldn't say that the fact that the ship is small makes it easier.
No, it's the other way around, maybe.
I think it's even the other way around. Yeah, so it's more challenging to say so. We have a small vessel which can be really sensitive to changes in operation. I think that there we come again into another topic, and this topic is again it brings us back to the regulations. The regulations that we have in place in shipping, but especially in inland navigation, because in seagoing shipping, in the last, I think 20, 30, even 40 years, the things have considerably changed. The attitude has changed, the mindset has changed.
Okay.
It has been enabled for people who have fresh ideas to have their say. I mean, not everything is roses. But if we look into the rules for seagoing ships, we are going to see that, let's say, alternative solutions for fire safety have been a part of SOLAS for now decades. We are going to see that we have damage stability rules which are probabilistic, again almost for decades in different for different ship types, but nowadays for all ship types we have the probabilistic damage stability standards. Then we have recently introduced, not as a mandatory code, but let's say something which is being experimented with, the second generation impact stability criteria, which implements physics, first principles, gives, let's say, different tiers of assessment, gives an opportunity to operate a ship even if it does not pass the stability criteria, which is a total novelty. So you can operate a ship, but in a restricted manner. So you can operate in certain operational conditions, or you can operate in certain environmental conditions for which you do pass the criteria, but for the ones that you do not pass, you cannot. So this is a completely...
It sounds very paradoxical.
Yeah, but it's a completely novel way of thinking.
Yeah.
At the same time, nothing new happened in inland navigation in that respect. We're very much behind in that sense, and the rules that we have are mostly based on our previous experience.
Yeah.
And sometimes it's even worse. It's in the absence of experience. When you look into let's say some details of the technical standards for inland vessels, you're going to recognize that actually, whenever we did not have an adequate response, we borrowed something from the rules for the seagoing ships. And when we borrowed that, sometimes we didn't really think much how we borrow. So, it was like an idea, if it is good for seagoing ships, it must be good for inland vessels. Sometimes it works, other times it does not work. So we have a strange combination that we have, let's say, rules which are based on experience with our own inland vessels, and we also have some sort of an addition based again on experience with some completely different vessels. So, they have nothing to do with the ships that we operate on inland waterways.
Right.
And then we try to introduce unconventional ships. And then we see, I mean, if we really want to see, we are going to understand that the rules we have, because they are based on experience, and we do not have experience with unconventional ships, then the rules, at least there is a question mark if these rules apply or not. So we need to critically address this. And we have seen this very, very clearly with AUTOFLEX ship design, because we have a vessel which is supposed to sail without human operators on board. We have electric propulsion, and of course, unmanned or uncrewed, let's say, shipping is something completely new. Really, I mean, new in also in sense that it is not being implemented yet. Yeah. Electric propulsion is not that new, but still relatively new. And depending on how we do this electric propulsion, there are things which are, not being tested enough and not being still well understood.
But isn't there a lot of arguments that actually electrification of ships simplifies that? Because at least in ocean-going ships, if you're using heavy fuel oil as your propulsion mechanism, there's a lot of maintenance systems, there's a lot of things that requires a human being on board. Yeah. And actually going electric would sometimes, at least from what I understand from my very limited knowledge of this, which actually simplifies some of those processes, which would make it easier not to have people on board. correct?
I completely agree. I mean, it should go into that direction, that electrification would facilitate automation. But then there is what we have in AUTOFLEX are swappable battery containers as energy sources. And then there is a requirement that these swappable battery containers should be placed in a specific place.
Yeah, actually, could you elaborate on that? That's a very interesting finding, I think.
So that's first of all, there was a requirement which was related to redundancy.
Yes.
So in some previous editions of Estrin, if you have batteries, if you have this electric propulsion, then you need to have redundant energy source, which would mean for the AUTOFLEX ship design, it would mean basically 2 energy containers on board. So to have this redundancy. Then this has been changed, but it still affects us in sense that the number of energy sources. So if you have 2 propulsors, as we have, so we have 2 azimuth ducted thrusters, then you still need to have the same number, so 2 energy sources. So we need to have these battery containers are relatively heavy.
Yeah.
So we need to place them somewhere on board, and then we need to follow the guidelines for the placement of swappable battery containers, which were issued by CESNI. Now these guidelines say that if you want to place a swappable battery container in the cargo hold, then you need actually to build a wall around it.
A wall?
Yeah, exactly. It's a steel bulwark that you need
for fire safety reasons, or?
I assume for fire safety reasons. And then once you do that, you must not change the position of the swappable battery container. Now you know, as a former man on board, you understand that when you transport containers, you cannot be picky about
the way you put them.
So you really need to, so you want to achieve as far as possible even keel. You want to achieve so longitudinal center of gravity, vertical center of gravity from the point of view of stability. And then you arrange your containers in such a way.
I would also add that if you're doing multiple stops, that's another parameter.
Exactly.
You don't want to put a container in the bottom of your ship, which goes off in the next port.
Exactly. So it's not only stability, not only flotation, but it's also practical handling of the cargo. Yeah. So you need to take this into consideration. Now, when you take one part of your already small cargo hold and dedicate it to swappable battery containers, and then there is, on top of that, there is a requirement that no cargo container can be placed on top of a swappable battery container. So then you lose additional slots for cargo containers.
Do you know why? Do you know what the reasoning is behind that?
The reasoning, I think, is fire safety, because once the fire starts in the battery container, I think it's hard to control it and so on. But we have I understand this argument from the point of view of 11,000 TEU Maersk container ship, but from the point of view of a 24 TEU small inland cargo vessel, I think it's rather easy to spot where the fire has been, ignited and to tend to it in an appropriate manner. But nevertheless, we have these constraints. That's the rule. And then this rule imposes constraints. So you can put it there. When you put it there, you must not change the position. And you would like to change the position sometime, because that would help you. To bring your ship to an even keel, or to achieve a certain center of gravity, and so on. Now, this is related to some other constraints. So we mentioned redundancy of sources of energy.
So you need 2, essentially, or more. Yeah.
We mentioned the positioning of swappable battery containers, and then of course there is a mandatory requirement which has nothing to do with the fact, or has something to do, but it comes in the let's say second row, with the fact whether the ship is manned or not. So you need to comply with stability regulations.
Yeah.
Now, when you go to the stability regulations, you have basically two achieve, to simplify, you need to achieve a minimal metacentric height. This minimal metacentric height is guided by two criteria. One criterion is to have small angle of heel. So the angle of heel under the action of external moments should be less than 5 degrees, or the angle of immersion of the deck. That's one criterion. And the other criterion is if you achieve with this first criterion, if your minimal metacentric height is below 1 meter, then it's a no-go. It has to be at least 1 meter.
Okay.
Which in practice for AUTOFLEX vessel means that we can achieve with, let's say, 0.6 meters, we can achieve that our angle of heel is 2 degrees. 2 degrees you don't notice.
Yeah, no.
I mean, it has no influence on your operation and so on. But nevertheless, we must achieve 1 meter. Why?
Ah, okay, yeah.
So then, but the problem is when we move to 1 meter, this means that we need to have a different vertical center of gravity. And this does not play for us in the sense that we need really to have very, very heavy containers in the first tier and very light containers in the second tier, which brings us back to the fact that when we really handle the containers, we cannot pick. You know, we cannot go to a port and say, today I'm taking only the heavy containers in the first tier. And in the second tier, give me only the light container. I mean, it doesn't work like that, right?
No.
And on top of that, I say, but here I have energy containers, so please don't place anything on them. So we see that we have some rules. It doesn't mean that these rules are let's say, bad.
No, they come from a place,
but
you know.
Exactly. They maybe they are good for something else. But for unconventional vessel, such as the one that we have designed within AUTOFLEX, these rules they don't seem to work well.
Is that particularly difficult for a CMT Class 2 ship then? Because I'm thinking it's smaller.
Exactly. Bigger. Exactly. So if we went to SEMT 4 class, which was also seemed to be a good platform for developing a new AUTOFLEX design, we would have less problems in that respect.
Because I'm thinking intuitively that the weight of one container as a share of the total ship weight is higher.
Exactly.
For the small ship.
Exactly.
So you are even more vulnerable, in lack of a better word, you know, to where you place your things.
Exactly. And then to add on top, so one thing, and one very important thing, is that the rules that we have, they do not consider unconventional ships in a proper manner, because these rules are not capable of considering. They were not devised in such a way that they can take into account the novelties, the new technologies that we introduce. Simply because these rules are, as we say, reactive.
Yeah, and it can also be difficult to predict all the, I would say, infinite amount of futures that exist out there. So,
of course, but then we need to base the rules not on the experience. We need to base the rules, and I mean, nowadays with all the simulation techniques that we have, we can base it on the experience that we do not have, because we can simulate the experience. We don't need to experience something as we had to before. Now we can simulate the experience, and we can learn from the simulation of the experience.
In a Bulgar way, we don't have to lose, it's going to sound Bulgar, I apologize, but we don't have to lose people's lives, or actually have like injuries on board before we start changing the law.
Exactly. We can simulate and see whether there will be fatalities or not. Whether there will be casualties or not. Whether there would be damage to the cargo or not.
Right. Another thing that's quite
whether there will be lost cargo or not. And now to complete with the stability rules, we have also an opportunity to carry secured containers, because in inland navigation it is normal to carry unsecured containers, which means you just place them on top of each other, no lashing. It's just the friction in between.
No twist lock either.
No, nothing.
Okay.
Yeah. If we want to carry secured containers, then the stability rules are milder, so they do not require 1 meter, they require half a meter. This is easier to attain, But who is going to secure the containers on an unmanned vessel?
Yeah, it would be the port. But yeah,
That's a question, because there are different ports, and I think there are also different procedures and different customs and so on. So, but I mean, it brings us to
That's a good point, because also, so how I'm involved in the AUTOFLEX project is primarily through business modeling and sort of making this idea operational, right?
Yeah.
And what I've always struggled a little bit with in the autonomy landscape is this exactly what you're saying, Igor. If there's no one on board to secure the lashing of the container, then that will have to be done by a port terminal, let's say, hypothetically. Which means all of a sudden it's the port terminal stewardess that is liable, responsible for something vis-a-vis the intactness, in lack of a better word, of the cargo, which is something that's written into a charter party with the ship operator. You know, so the ship operator might be liable for cargo damages, but cannot push that liability onwards to the terminal, although it is the terminal who have secured. It's so interesting when you start fiddling around with this.
And then add to this equation also the fact that on the port side, people try to automate things. So they also want to remove people from the equation. So where are the stevedores actually?
Yes.
I mean, so at the end of the day, your ship should pick containers, should be very picky in picking the containers. Then the ship itself should lash the containers, or I don't know, something else should lash the containers. Or we change the rules.
Yeah, or we change the rules.
Or we change the rules, and then we look into the stability calculations, and then we see what we actually need.
Yeah.
So we do
what we need, sort of from you feel like I wouldn't say a theoretical perspective, but from like a more scientific perspective.
From a more physical perspective.
Sorry, thank you.
So we introduce physics.
Yes.
And we calculate things in using physics. Not simplifications, not approximations. Yes, we still need to approximate here and there, of course, but increasingly less so. So we made a big step, but inland navigation did not pick this up yet, and there we have an issue with the rules. Now another thing which is important for the AUTOFLEX ship design, and this is also important from inland navigation point of view in general, these dry cargo ships, they should be capable of carrying different cargo. So not only the containers. So we designed the AUTOFLEX vessel around the idea that it carries unitized cargo because it would facilitate cargo handling.
Yeah.
Okay, but the good point is, the good side of the design is that it is actually an excellent bulk carrier. Maybe it is even a better bulk carrier than a container carrier. And in the same time, in inland navigation, you have very often a fact that simultaneously containers, bulk cargo, and even break bulk cargo are being carried in the very same cargo hold. But your cargo hold has swappable battery containers inside, which must not move.
Of course.
So it becomes very intricate. So we have multiple constraints.
I haven't thought about that. That's such a good point. Yeah. Okay, sorry. No, but I'm just like being a little bit baffled, because of course these things have been put in place for, as you say, a fire safety perspective. But sometimes there might be what you call like domino effects, which you're not aware of. When you actually start expanding.
And this brings us to the beginning of this conversation. Because if we focus on implementation of one new technology and we forget about the holistic picture, we forget about the ship design as a whole, then we miss this point.
Yes.
We say, okay, swappable battery containers are a solution for the future. Maybe so, but first we need to consider for which ships. What is the size of the ship? How does the ship operate? Where does the ship operate? So yes, I think we base our let's say, sometimes we base our projections to future on a very limited experience, which is very, very strange, because nowadays we have so many opportunities, again, to simulate this experience. and to do in a relatively fast way things that we could not have done before.
And the simulation don't even have to be computerized, because in DST, you have a towing
We
thing,
can-
you know, so you can actually simulate things at a scale.
Exactly.
Yeah.
It can be physical demonstration,
Yeah,
can be physical testing. This is the point, and this is one of, let's say, the thing which is closest to my heart in AUTOFLEX, that we were, to my knowledge, at least in inland navigation, the first ones to look into the effect of these new technologies on ship design from a holistic point of view, taking into account classic naval architecture disciplines, structures, stability, flotation, safety in general, cargo handling, and so
but
on.
especially this operational part, Igor, I think it's so interesting, because this thing you say with, like, for instance, all of a sudden you have a battery container, which has nothing necessarily to do with autonomy, right? Because you could have an unmanned vessel with the same issue. But these things seem to be introduced legally from quite sort of like I don't know if I call it segregated point of view or siloed, but it's very focused on one particular thing. As you say, well, okay, if we have to comply with this, then all these 99% of legislation we cannot comply with potentially, you know, or the business case doesn't hold, or you know, whatever it is.
Exactly. So the showstopper, we go, you know, full throttle with automation.
Yeah.
And then the showstopper is stability.
Yeah.
And you know, and we think, well, stability is an ancient thing. It has been solved. Yes, it has been solved for ancient ships, but for the new ones, we need to reconsider.
And when you say stability, is it a physical type of stability, or this legal? You have parameters that you need to abide by?
I would say legal. So you need to chase some parameters, and you don't know why. So you can achieve sufficient stability. So it also depends a little bit on the cargo. If you have dangerous cargo, then you need to comply with the damage stability rules,
of course,
according to ADN. There you can, it increases the required metacentric height. It may become impossible, it may become very difficult, because then it places another constraint on how do you configure the containers, how do you arrange the containers. But you can also play a little bit with the subdivision of the vessel, which we didn't do in AUTOFLEX, because simply there was no.
And we don't look at dangerous cargo also because another thing you have, which we're also not looking at AUTOFLEX just from a scoping perspective, is fire suppression. As far as I know, we don't look at this. And of course, if you have dangerous cargo on board, there's also like, how do you prevent explosions or mitigate or.
But I think that the good thing with AUTOFLEX is actually that we have from my point of view personally, the added value of research projects should be starting a discussion on a certain topic. We have started this. We have triggered some questions which need to be solved. So we are showing actually where the gaps are. We are showing where are the problems that we need to tend to, and how we need to tend to these problems. And I think it's a good start in the direction of let's say, having actually at some point small inland cargo vessels which are, let's say, electric, zero emission if you like, and automated.
Yeah, whatever automated means also, because as you said earlier,
it's a big topic, and whatever you say is wrong, you know.
And I'm looking at my watch here because we're running a little bit out of time. And one thing I really want to talk with you about, Igor, which we unfortunately don't have time for, but that just means there's another conversation. I mean, you become a quite close friend also, sort of outside of work, which is you know, because I feel you have a very interesting approach to these things. Very few people look at it first and foremost holistically, but also a little bit more philosophically, you know, like taking a break and saying, what happened 100 years ago? Why are things in place the way they are in place? Are these ultimate truths? For instance, like, do we need to have 1 meter, as you said before, you know, or is that sort of an ultimate truth, in lack of a better word, with a little bit of a safety margin on top, you know, or could that perhaps be half a meter? Or these sort of questions are quite important, especially if they're empirically driven, saying, okay, we have done this analysis of historical ships. We have found that there are these sort of things. Now that we have a new ship design, there's these other parameters that occur that are not in compliance with the rules. I wouldn't say what is wrong, but what needs to happen? Do we need to do another design, or is it actually the rules that are maybe too rigid for those type of ships. Because I mean, how I'm often thinking about it as well is that we have classification on ship based on their cargoes. So you have a bulk carrier that has to follow some rules. I used to sail tankers that have to follow some rules in container ship. And of course there is like the broad umbrella that applies to all ships, but then you have additional things based on the type of cargo.
Exactly.
And I'm also always thinking like, wouldn't it also make sense to have additional things or exemptions or whatever you want to call it based on, you could say minimum level of autonomy, but all these other parameters are not necessarily cargo, could be propulsion, for instance, right? Like all these other size of the ship, etc., etc.
Indeed.
You know?
Yeah, I agree.
Igor, it's been a pleasure. I'm going to give you my hand.
Likewise.
We will talk a lot in the future.
Me.
No, thank you for taking the time. I really want to talk more, as I already mentioned, about flexibility, because that's something we have already discussed. And I'm so sad I didn't record when we discussed it the first time. But I was just given an opportunity to discuss that again, because the reason the project is called AUTOFLEX is autonomous and flexible.
Yeah.
And we've almost only talked autonomous.
Yes, I don't think that we have discussed flexible enough, or
at least not in this conversation.
Exactly.
You can say,
Yeah.
Good.
Indeed.
Igor, it's been a pleasure.
Likewise. Thank you.